Hi, and welcome back to Learn with Islam. Today we are diving deep into our transformative concept in software design, which is hexagonal architecture. This topic holds incredible relevance, especially in industries like banking and finance, where software complexity can be a major challenge. I'll be sharing insights from my 28-year experience in software development, working on global scale projects, including modular banking systems that relied heavily on this architecture. By the end of this video, you will not only understand the theory, but also the practical implementation details, tools, and real-world business advantages that hexagonal architecture brings to the table. So what is hexagonal architecture? The hexagonal architecture, also known as the ports and adapters pattern, was introduced by Alistair Cockburn. Its goal is to simplify complex systems by decoupling the core business logic from the application's external dependencies. Imagine a hexagon with the core logic in the center. Each side represents an interface or port for interacting with the external world, such as databases, APIs, or user interfaces. The architecture ensures that the business logic, the heart of the application, remains isolated and untainted by changes in the surrounding infrastructure. This makes system modular, maintainable, and testable as well. So why is hexagonal architecture relevant today? In today's fast-paced industries like banking, modularity is critical. Financial systems need to scale seamlessly, adapt to new regulations, and integrate with emerging technologies, all without causing disruptions. Hexagonal architecture provides the flexibility. For example, in a core banking system, you can replace the database layer or upgrade a third-party payment API without touching the business logic. This agility reduces downtime, lowers the cost of ownerships, and improves the customer experience by allowing faster delivery of new features. So what are the core principles of hexagonal architecture? First of all, we need to have separation of concepts. The architecture divides the application into three main parts. First of all, core business logic, which represents the domain model and use cases, unaffected by external changes. Then we have got ports, which are interfaces that define how the application interacts with the external system. And obviously, we have got adapters, implementations of the ports, connecting the core databases, APIs, or UI. So this separation ensures that each component has a single responsibility following the solid principles. Then we have got dependency inversion. Dependencies flow inward. External components depend on the core logic, not the other way around. For example, a banking system's transaction validation logic should not depend on the database. It should work independently, making the database an implementation detail. And also, we need to take care of testability. Since the core logic is decoupled, you can write unit tests without worrying about the database or network layers. This results in faster and more reliable testing cycles. So how we can implement that in the real world? If we talk about modular banking system, so let's discuss a practical example, implementing hexagonal architecture in a modular banking system. First of all, if we talk about core business logic, this includes entities like customer, account, and transaction, and use cases such as transfer funds or generate statement. So all business rules reside here, written using domain-driven design principles, which is DDD. The domain model reflects the real-world concepts. For example, the rule of overdraft protection should be part of the core logic, ensuring that this feature works regardless of the database or UI used. We also need to define ports and adapters. So for ports, we need to define how the application interacts with external systems, like REST APIs for client interactions, messaging protocols for inter-services communication. And also, we need to write adapters, provide a specific implementation, such as database adapters for PostgreSQL or MongoDB. Or maybe messaging adapters for RabbitMQ or Kafka. Or maybe we can have API adapters for integrating with third-party payment systems. So what will be the business advantage then? First of all, we can achieve modularity. Each module, like loan management or customer onboarding, can evolve independently. Also, integration will be very easy. Easily integrate with emerging technologies like blockchain for secure transactions or AI for fraud detection. And ultimately, scalable. Scale components like transaction processing independently by deploying them in a microservices environment. Let's implement it step by step using different tools, just to give you an idea how it can be practically possible. First of all, we need to design. We need to identify core use cases and domain models. Use UML diagrams to visualize entity relationships. Then we need to define ports as interfaces such as account repository or notification service. Then obviously we need to choose the right framework. For Java, a Spring framework supports dependency injection, ideal for implementing ports and adapters. For PHP, Laravel with its service container provides flexibility in defining adapters. After that, we need to write the core logic. For example, implement the transfer funds use case, validating source and destination accounts, calculating fees, and generating a transaction. After that, it's very important to build adapters. We need to create a database adapter using JPA, Java Persistent API, or Eloquent ORM. We can develop an API adapter for external integrations like a payment gateway. For testing, we need to write unit test for the core logic using tools like JUnit or PHP Unit. Use mock objects for ports to isolate the business logic. For deployment, we can deploy the core logic as a standalone service in a Docker container. Use Kubernetes for orchestration. So what are the challenges in best practices? While hexagonal architecture is powerful, it comes with its challenges. There is a learning curve. Teams must understand domain-driven design and dependency inversion. And there is a bit of overhead as well, because setting up ports and adapters can seem excessive for small projects. So what are the best practices then? In my experience, we can start with clear domain modeling to avoid over-engineering. Use CI/CD pipelines to automate testing and deployment. And also regularly refactor adapters to keep external dependencies updated. Hexagonal architecture is more than just a pattern. It's a mindset. By decoupling core business logic from external systems, you gain flexibility, scalability, and testability, qualities that are indispensable in today's complex software landscape. I hope you found this discussion valuable. If you'd like me to dive deeper into a specific aspect, drop a comment below. Don't forget to like, share, and subscribe for more high quality content and advanced software topics. See you next time and have a nice time ahead.